Welcome to Spaceverse, your portal to cosmic adventures. For millions of years, something truly astonishing has been racing through the vastness of space, almost at the speed of light. Galaxies, which typically sit millions of light years apart, are often pulled together by the invisible force of gravity. This cosmic tug-of-war draws hundreds, sometimes thousands, of galaxies into tight clusters, causing them to squeeze together. As these massive galaxy clusters draw closer, gravity's grip tightens, forcing them into explosive, cataclysmic collisions. These cosmic crashes are so powerful that once they start, they can't be undone. And the best part? Scientists have recently uncovered one of these spectacular collisions while studying the universe. Intrigued by the latest discovery? Stick around as we unravel the mystery of the incredible force that's been hurtling through space for eons, shaping galaxies and leaving its mark on the cosmos. Now let's bring it a little closer to home and zoom in on our very own cosmic neighborhood. Our solar system is situated within the Milky Way galaxy, a sprawling collection of stars and planets that appears as a hazy band of light when observed from Earth. The Milky Way itself is part of a much larger cosmic structure called the Virgo supercluster, which in turn is nested within the vast Laniakea supercluster. Astronomers believe the Milky Way is far from alone in this cosmic web. It shares the universe with countless other galaxies, and within it, between 100 and 400 billion stars, each with their own planets. Our solar system orbits the galactic center about 27,000 light-years away, positioned on the inner edge of the Orion Arm. And at the very heart of the Milky Way sits Sagittarius A, a supermassive black hole, holding a staggering 4.1 million times the mass of our Sun. As we peer deeper into our galaxy, we find that stars and galaxies orbit the center of the Milky Way at an incredible speed of around 220 kilometers per second. This fast pace breaks the usual rules of orbital motion, leading scientists to theorize the existence of an unseen force keeping everything in check: dark matter, a mysterious substance that doesn't interact with light but is believed to make up a large portion of the universe's mass. From afar, the Milky Way itself is also racing through space at about 600 kilometers per second. Some of the oldest stars in our galaxy are nearly as ancient as the universe itself, having formed shortly after the Big Bang. Alongside the Andromeda Galaxy, the Milky Way is one of the two largest members of the local group of galaxies, with an estimated mass between 540 billion and 890 billion times that of the Sun. Thanks to our ever-evolving technology, we're gaining unprecedented views into the vast wonders of our galaxy, from the shimmering light of billions of stars and planets to the mysterious white dwarfs, neutron stars, and even black holes. Between these celestial objects lies the interstellar medium, a vast expanse of gas that fills the space between stars. But as awe-inspiring as our Milky Way is, the true drama often unfolds far beyond our galactic neighborhood. Just recently, astronomers made a jaw-dropping discovery a staggering 730 million light-years away from Earth. In their pursuit of the universe's most colossal and brilliant events, they uncovered something extraordinary: a massive collision between two galaxy clusters. In February 2022, the Journal of Astronomy and Astrophysics published a groundbreaking study showcasing one of the most detailed images ever captured of a massive shockwave. This shockwave ripples through the A1367 galaxy cluster, the result of a cosmic collision between two galaxy groups. A1367 is an energetic hub, home to around 550 galaxies, all slowly merging into one colossal cosmic entity. The shock wave triggered by this cataclysmic event stirs up a disturbance of epic proportions, one that is invisible to most telescopes but awe-striking to those able to detect it. Experts describe this shock wave as an enormous disruption, stretching from both ends of the merging galaxy cluster, observable only in radio wavelengths. Using the powerful Meerkat radio telescope array in South Africa, researchers were able to capture these radio relics on both sides of the shockwave, revealing intricate structures that go far beyond what anyone had previously imagined. Francesco Di Gasperin, the study's lead researcher and a visiting scientist at the Hamburg Observatory, explains that these shock waves act like colossal particle accelerators, hurling electrons to near light speeds. The result is a dazzling pattern of light filaments that not only map out massive magnetic field lines, but also pinpoint the areas where electrons are being accelerated at mind-blowing velocities. Though this shockwave is a recent discovery, its origins date back nearly a billion years, to when the two galaxy clusters forming A1367 collided. When galaxy clusters merge, they release immense amounts of energy, as these clusters rank among the largest gravitationally bound structures in the universe. Researchers think this collision is one of the most powerful energy releases since the Big Bang. During this event, a surge of electrons was ejected, traveling across space at speeds up to 1,500 kilometers per second. As they crossed magnetic fields, these electrons emitted radio waves, which Dr. Gasparin and his team detected using Meerkat. To further analyze the shock wave, they also turned to the Chandra X-ray Observatory, which offered additional insights into A1367. Looking closely at the image, you can spot the core of this galaxy cluster with its 550 galaxies, surrounded by vibrant red hues that represent the powerful shock waves generated during the formation of the supercluster. This discovery marks a significant leap in our understanding of galaxy cluster mergers, offering insight into the intricate processes involved in these vast cosmic collisions. Interestingly, sometimes what scientists don't find can be even more puzzling than unexpected discoveries. Back in 1981, a group of astronomers at the University of Michigan set out to measure the redshifts of various galaxies, hoping to create a 3D map of the universe. But as the map took shape, they encountered something truly surprising: a vast, nearly empty region around 700 million light-years from Earth. This void, over 330 million light-years across, contained virtually no galaxies. Initially called the Great Nothing, it was later named the Boötes Void, as it lies within the constellation Boötes. Further mapping of the universe showed that galaxies tend to group along cosmic filaments, creating enormous empty spaces between them. These voids, which make up nearly 80% of the observable universe, range from 30 to 300 million light-years wide, and the Boötes Void is one of the largest, earning it the title of a supervoid. The existence of these voids is due to the delicate balance of cosmic forces in the early universe. At first, the universe was a dense, uniform soup of matter. However, tiny quantum fluctuations caused slight variations in this even distribution. Denser areas attracted more matter, strengthening their gravitational pull and drawing material from less dense areas. This led to the formation of dense clusters and the growth of vast empty voids, all while the universe continued expanding. Over time, these gravitational interactions and cosmic expansion shaped today's cosmic structure, with galaxies lining up along filamentous networks and immense gaps occupying the spaces in between. Astronomers at the University of Alabama, Huntsville, led by Chong Ji, recently made a breathtaking discovery: a colossal cloud of hot, faintly glowing plasma drifting through space, and it's even larger than the Milky Way. This immense gas cloud, called the Orphan Cloud, has defied expectations by staying intact for hundreds of millions of years instead of dispersing. By studying its X-ray emissions, researchers estimated its mass to be about 10 billion times that of the Sun, highlighting just how many surprises the cosmos still holds. Located in the Leo galaxy cluster, or A1367, around 300 million light-years away, this cloud likely originated from a galaxy within that cluster. Its incredible size suggests that it came from a massive parent galaxy. What's even more intriguing is how it has held together over such a vast distance. The team suspects a magnetic field may be keeping it intact, even after it drifted away from its home galaxy. Discoveries like the Orphan Cloud shed light on galaxy evolution, showing how galaxies can be stripped of their gas as they pass through the intercluster medium, a process that gives scientists clues about conditions in the early universe. Each new discovery reveals more of the universe's mysteries, inspiring us to question our place within it and driving our endless curiosity to explore further. And that's it. Thanks for watching Spaceverse. We hope you enjoyed exploring cosmic collisions, supervoids, and the mysterious Orphan Cloud with us. Don't forget to like, subscribe, and hit the bell for more space mysteries. See you next time.